All right, we're finally going to get our hands dirty and factor these simple trinomials. Remember, these trinomials will always look like x squared plus bx plus c. More specifically, the x squared has a 1 in front. That's what makes it a simple trinomial in this case. So let's take a look at part A. We want to factor y equals x squared plus 3x plus 2. Step 1, I want you to write out your a, b's, and c's. Go ahead and do that. When you're ready, unpause the video. So hopefully you got 1, 3, and 2. They're just the numbers that are in front of x squared, x, and the constant by itself. All right, step 2, we want to find two numbers, m and n. These are just placeholders. You can call it an apple and an orange or other letters like c and d, whatever you want. But we want to find two numbers, m and n, so that two things happen. Number 1, we want m times n to equal the constant c. And number 2, we want m plus n to equal the coefficient b. So in other words, we want our two numbers, m times n to equal 2 and m plus n to equal 3. So think to yourself, what two integers multiply to 2 and add to 3? Think positive, think negatives. When you're ready, unpause the video. So always start with thinking about your multiplication. What two integers multiply to 2? Well, we have 1 times 2 or negative 1 times negative 2, right? Because two negatives also give you a positive. Now, if we add these up, 1 plus 2 gives us 3. Negative 1 plus negative 2 gives us negative 3. So which one is the pair that we want? Well, the numbers that we want are going to be 1 and 2. So that means that m and n are going to be 1 and 2. The order doesn't matter. M could be 1, n could be 2, or I can switch them. M could be 2, n could be 1. It doesn't matter. But now the third step, this is the nice easy step. Our trinomial, which was x squared plus 3x plus 2, this is what the question gave us, is going to equal x plus m times x plus n. So I'm going to swap out my m and my n for these numbers that I just found. Again, order doesn't matter. So we were just able to successfully factor this trinomial. We just found that x squared plus 3x plus 2 is x plus 1 times x plus 2. And guess what? Factoring is just the opposite of expanding. So once we have an answer, we can actually work backwards and see if the answer is correct. So let's go ahead and do a quick check here. We want to expand x plus 1 times x plus 2 and see if we end up back at the original. So x times x, that is x squared. X times 2, that is 2x. So my x's are happy because she went and met everyone next door. Okay, now this positive 1 wants to go meet everyone next door. So positive 1 is going to go shake hands with x. So 1 times x is 1x. Positive 1 is going to go meet up with 2. 1 times 2, that's 2. So now we multiplied everything through, we expanded, let's simplify. We have an x squared. Oh, there's two things with x's, so in total it's 2x plus x, which is 3x. And then we have a plus 2. So we do indeed end up back at the original, meaning that this is indeed the correct answer. This is the factored form of this polynomial. Now, I know some of you guys might be a little bit more visual. You might be thinking, okay, cool, like I was able to maybe find two numbers that multiply to 2 and add to 3, but why am I doing that? So essentially what I want to do is bring back our factoring box here. So remember, the original question was x squared plus 3x plus 2. So what I want is two things that multiply to x squared. What times what gives us x squared? Well, x times x gives us x squared. And then I want a constant of 2. What times what gives us 2? Well, 1 times 2, right? If you go across and you go down, 1 times 2 does indeed give us 2. But we have to fill out the rest of this multiplying box, this factoring box as well. Well, how about this box right here? Well, this is x times 2, which is 2x. And how about this box right here? Well, this is 1 times x, which is just a single x. So in total, we have x plus 2x, which is 3x. So indeed, the factors that we want are x plus 2 and x plus 1. So you can use this to help you visualize it, or I personally prefer the shortcut because it's a lot quicker. You just have to decide on two numbers that multiply to C and add to B. All right, part B, let's take a look at this one. We want to first list out our A, B, and C values. A is the number in front of x squared, so we have a hidden 1, so A is 1. B is the number in front of x, that's -2. C is the number that's on its own, the constant, which is -15. Step 2, we want to find two integers, m and n, such that two things happen. I want you to write down those two things, and when you're ready, try to find out what your m and n have to be, and then unpause the video. All right, so the two things that we need to happen are that m times n have to equal c, which is -15, and m plus n has to equal b, which is -2. So we have these two orange statements. Always start with the multiplication, always. Don't try to think of two numbers that add to -2. There's way too many. Always start with your multiplication statement. So what two numbers multiply to -15? If that negative is bugging you, just think +15. What two numbers multiply to +15? Well, we have options here. We have either 1 times 15, or we could have 3 times 5. But both of these multiply to +15. We want -15. When I have two numbers multiply together to give me a negative, what has to happen about one of them? Well, one's going to stay positive, but the other one has to be negative. So let's put a negative somewhere. I'm going to put a negative in front of the 1, so I have -1 times 15. Oh, what if instead I decided to put the negative in front of the 15? Well, that's another option, isn't it? Okay, and for 3 and 5, again, I could put the negative in front of the 3, or I can switch it. I can put the negative in front of the 5. Now, order doesn't matter. So I don't have to say, 15 times -1, because that's the same thing as -1 times 15. The numbers are the same. I have a -1, I have a 15. The order here doesn't matter, so we don't need to switch the order of our numbers. We just switch the order of the negative signs. So in total, there are 4 possibilities. Now, within these 4 possibilities, now we need to figure out which two of these add to -2. So let's take a look here. First option, if I add -1 and 15, well, I'm going to get 14. That's not right. If I add 1 and -15, I'm going to get -14. Again, that's not right. I need -2. Let's keep going. What if I add -3 plus +5? Well, that's going to give me +2. Ooh, I'm getting close, but not quite. I need a -2. How about down here? 3 plus a -5. Ooh, that one gives me -2, meaning that 3 and -5 are our numbers. So m and n are going to be 3 and -5. The order doesn't matter. I can say m is 3, n is -5, or m is -5, n is 3. Now, in step 3, we write out the factored form. So remember, the trinomial, the simple trinomial, was x squared minus 2x minus 15. That's going to equal x plus one of your numbers, x plus the other number. Doesn't matter which order you put them in. So I'm going to say x plus 3 and x plus -5. But of course, when we have plus a -5, that's awkward. A positive and a negative make a negative, so I can just rewrite that as x minus 5. This is the factored form of the simple trinomial. I'm going to leave it as an exercise for you to expand and simplify, and you should end up back at the original. All right, part C. This one you're going to do mostly by yourself. First, you're going to find your A, B, and C. That's your first step. Second step, you want to find two numbers, m and n, such that two things happen. They have to multiply to something, add to something, figure out what those somethings are. And then third step, you want to factor this expression into 2 brackets. So go ahead, give this a try. If you ever get stuck, just unpause the video, but if not, you can check your answer at the end once you unpause the video. So in step 1, you should have gotten A equals 1, B equals -8, C equals 12. And then we want to find two numbers, m and n, such that they multiply to C, which is 12, and they add to B, which is -8. And we always start with the multiplication first. So what two numbers multiply to 12? Now, a lot of you guys would have come up with positive integers, right? 1 times 12, 2 times 6, 3 times 4. And at this point, if you keep going, you'll also have 4 times 3 and so on. But notice that we have a repeat. 4 times 3 is the same as 3 times 4. The instant you have a repeat, you can stop. We don't need it. But then when you try to add these numbers, they're all going to give you positives. Whereas if you look at your b, we have a negative number. So the instant you see a negative in your b, I know that my two numbers, m and n, at least one of them has to be negative. And since I need to multiply to a positive number, well, I need both of them to be negative. Otherwise, I'll end up with a negative, and I don't want that, right? So I need both negative numbers to be m and n, so that when they multiply together, they give me a positive 12, and when they add together, they give me a negative 8. So I'm going to make all of these negatives. And now let's see which ones add up to negative 8. This one adds up to negative 13. This one adds up to negative 8. This one adds up to negative 7. You will always be able to find one that adds up to the negative 8, exactly one of them. So our numbers here are negative 2 and negative 6. So all I have to do is plop them in my bracket now. I have x plus m, which is negative 2, x plus n, which is plus negative 6, which is just minus 6. So x minus 2 times x minus 6 is our factored form. And as an exercise, go ahead, you can expand this bracket, so do your whole FOIL or distributive method, multiply it through, and you should end up back at the original trinomial.